All right, today we're going to be talking about dividing with remainders, and you should have your notes on page 23 glued in, and you should have your practice glued in on page 24. They're on separate pages, so you're going to have to flip to the next page. They are not side by side today. Okay, today when we're dividing with remainders, you need to remember our rules from yesterday where we talked about dad, mom, sister, brother, dog, rover, okay, the D and the R. So when we're looking at this and we have a problem, a word problem like what we see in front of us about Rancher Roger, okay, first we need to use our cube strategy where we circle all numbers, we underline the question, we box in keywords, we eliminate extra information. So we're going to start with that first to figure out exactly what I'm trying to solve for, okay? So first I'm going to start out with 2,653 horses. I want to circle that. He puts 2,600 in the South Corral. Is there anything I need to circle, underline here? 2,600. Please don't forget, sometimes our numbers can come in the form of words. The rest are placed in stalls in pairs in the barn. Anything important here?
In pairs.
In pairs. The rest, basically that means whatever's left over. Each stall holds 2 horses. Anything important here?
2 horses.
2 horses in each. How many stalls will he use?
Underline how many stalls will he use.
Very good. Remember, if I do, you do. Anytime we're taking notes, anything at all on the board, we are practicing good habits. Okay, so we have a total number. We've got 2,653 horses. He puts 2,600 in the South Corral. The rest are placed in stalls in pairs in the barn.
You're welcome, horses.
Okay, what's the first thing I need to do? What do I have to do first? What do you think?
Divide.
Not yet. I'm not ready to divide yet.
Subtract.
What am I subtracting?
2,653 and
I have one Savannah. I shouldn't hear anybody else's voice.
2,600.
Very good. So 2,600. So I want to subtract this first. Why do I want to subtract this first?
Because it tells us that he puts the last 2,600 of them go in the South Corral and the rest get put.
Because it says the rest are placed in the stalls. Okay, I don't even need to worry about the rest yet. I need to know how much the rest is because I've got to figure that part out first. So thank you, Savannah. We are going to be subtracting first. So if you're making the humming or singing sound, please stop. Thank you. Okay, we are going to subtract these 2 numbers. So after I subtract everything, I end up with 53. Okay, so I'm taking 53 horses. This is a lot of information in this problem. What am I going to do with that 53?
Divide it by 2.
Why would I divide that by 2?
Because each stall holds 2 horses.
Because each stall holds 2 horses. Okay, so I'm going to divide it by 2. Now, I'm going to follow my rules of dad, mom, sister, brother, bring down, and then rover, repeat if I need to. Okay. Let me push this down just a little bit. Okay. Can 2 go into 5? I'm just going to look at this one digit at a time. So if I'm just looking at this first digit here, how many times can 2 go into 5? 2 whole times. Okay, the multiplication part I've divided. The multiplication part comes next. What am I multiplying here? 2 times 2, which is 4. Okay, I've done that part. Check. So I'm going to subtract next. What do I have left over?
1.
Okay,
Bring down 3.
bring down the 3.
6 times equals 12.
Okay, now I'm repeating my steps. So I'm now going to do 6 times up here because if I'm looking at 13, I know 2 goes into 13 6 whole times. So what is 2 times 6? 12. Okay. I have multiplied. I now need to subtract. I have 1 left over.
Remainder 1.
So it is a remainder 1. What does this mean? Each stall holds 2 horses. How many stalls will he have to use? I've got 1 horse left over. Okay.
26. No, but 27 because 27 plus the remainder.
Okay. So,
No, 26 plus the remainder.
26 plus the remainder, but can I have remainder 1 horse stalls?
No.
No. So if I want to make sure that horse gets put in a stall, how many stalls do I have to use? 27. I have to round it up. Okay, even though there may be an empty stall, it's okay. I still have to use a whole nother stall to house that horse. Okay, so what this is showing right here is that we have 26 pairs. We have 26 pairs plus 1 extra.
Where's the pairs? Gotta give us some pairs.
So we've got this lonely little horse right here in a stall all by himself. We can't leave out a horse, which means that we can't just use 26 stalls. We have to use 27 stalls. Yes, question.
If we have 26 pairs, I don't have 26 pairs.
Where are the pairs? You gotta give us the pairs because he said they're pairs.
Okay, next one. Rancher Roger buys 3,633 pounds of oats. He stores 3,500 in a silo and the rest in troughs in the barn. Each trough holds 9 pounds of oats. How many troughs are completely filled? Okay, so what do we need to mark up here? First sentence. Is there anything in the first sentence?
The numbers.
Jeremy.
3,633.
Okay, very good. Second sentence. What do I need to know in the second sentence? 3,500.
Yes.
The rest in troughs in the barn. Next sentence. Each trough holds 9 pounds of oats, and then underline how many troughs are completely filled. Completely filled. Okay, so very similar to the last problem, what do we need to do first to figure out what number I'm even working with? Subtract.
3,633 and 3,500.
So 3,633 pounds minus 3,500 pounds. So I can see that I am working with 133 pounds. Now each trough holds 9 pounds of oats. So what do I need to do with 133?
Divide it by 9.
Very good. Is everybody with us so far?
Yes.
Okay, 133 divided by 9. Can 9 go into 1? Nope. But can it go into 13?
Yeah.
How many whole times? 1 whole time. So a 1 goes up here in my quotient. 9 times 1 is 9, so I'm going to subtract 9. And what do I have left over when I do 13 minus 9? 4. Okay, what's my next step? Raise your hand. Bring down the 3. How many whole times can 9 go into 43? Raise your hand.
4.
4 whole times.
No.
4 whole times is correct. I would subtract 36. And I'm going to have to borrow when I subtract this time in order to do 13 minus 6, which is 7. Okay, so what do? I have a remainder. My remainder is 7. So 14 remainder 7. What does that even represent? 14 what? Remainder 7 what?
14 pounds in the troughs.
How many troughs are completely filled?
14.
14 are completely filled.
With
7 lines.
That's not how you spell R. Arg.
Do we have another trough that's filled? It's
Well,
filled with
it's-
something,
yeah.
but is it completely filled?
No.
It's not completely filled. Filled. Okay, let's look at our practice on the next page. It says find the quotient and the remainder for, ooh, we haven't done 2 digits yet. Let's skip that one. We'll do that one later. We're doing that on Monday. So let's skip down to number 2.
Why can't we do 2?
We are doing number 2. We're not doing number 1 because we haven't divided by a 2-digit divisor yet.
If you know how to, can do.
You can later. Okay, number 2. Find the quotient. What does quotient mean?
The answer.
Answer to what?
The problem.
The multiplication.
To a division problem.
Yeah. It's the answer to the division
Okay.
problem.
So we want to find the quotient and the remainder. So we're going to take 6,029. We're going to divide it by 8. Can 8 go into 6? My very first digit in the dividend. I've already explained why we're not doing number 1. 8 cannot go into 6, so I'm going to put a 0 placeholder up there and go over and look at 6D. So I won't go into 6, but it can go into 60. How many whole times can 8 go into 60? Very good. Which is?
56.
Good. So I would have 4 left over, and I drop that 2. Now, like I was showing you earlier, when we were checking our homework, you can drop this down so that you know that you're doing now 42 divided by 8. If that helps you, if you're like a visual person, you need to see that, you can do that. Okay, so how many whole times can 8 go into 42? 5 whole times. 8 times 5 is 40. After I subtract 42 minus 40, I have 2 left over. Do I have any other numbers to bring down?
Yes. 9.
9.
3.
So again, if I wanted to make this a little bit easier for me visually to see what I'm dividing next, I could do 8 into 29. How many whole times can 8 go into 29? 3, thank you.
27.
Which, 24. And I have a remainder 5. So the way I write that is 753 remainder R5. R5. So which answer choice matches that? D. Very good. Okay, last one. It's a word problem. What do you think we have to use? What strategy?
The circling.
Yep. What do we call that?
The
Cubes. Thank you. Good job. Okay. Connor sorted 4,817 rodeo tickets into 5 equal piles. Anything in this first sentence that I need to do?
4,817.
What do I do with it?
Circle it.
Circle it. Okay, what else? 5. What do I do with equal piles? Square it. Box it. Good. How many tickets were left over after all the piles were equal? Anything else I need to do but other than underline? Equal. What about it? Box it. Anything else? Left over. If I have something left over after I've made equal piles, what's that called? What's the leftover called? The remainder. Good. Okay, so we know we have to divide 4,817 by 5. Looking at this, I can already tell I cannot put 5 things into 4. So I have to bump over and look at 48. So 5 can divide into 48 how many times? 9. 9 times 5 is 45. Okay, so I'll do the subtract part. Add 3 left over. Bring down the 1. Now I'm doing 31 divided by 5. How many times can 5 go into 31? 6. What is 5 times 6? 30. I have 1 left over. Bring down the 7. Don't jump the gun, guys. Hold on.
If I jumped the gun,
Okay.
then I wouldn't be alive.
Now I'm going to do 17 divided by 5. How many whole times can 5 go into 17? What is 5 times 3? 15. So I have 2 left over. Okay, so I have 963 remainder 2. What does this mean? If you can eliminate the side conversations, it helps people around you to not be distracted. Okay, the question said how many tickets were left over after all the piles were equal? C. Very good. Okay. Today you have practice in Google Classroom, so open your Chromebooks, please. It is called division with remainders. I'm going to demonstrate it's just a drag and drop activity. So I will show you what to do in just a moment.